Dear viewers, Namaskar. Welcome to the lecture series on food technology. In this session, we will study about the topic vinegar. The topic vinegar will be discussed under 5 subunits such as 1. Introduction, 2. Types of vinegar, 3. Organisms involved, 4. Manufacture of vinegar, and at last we will be discussing about uses of vinegar. Introduction. Vinegar is a liquid consisting mainly acetic acid and water. The acetic acid is produced by the fermentation of ethanol by acetic acid bacteria. Vinegar must have been known to man for thousands of years since he apparently learned to produce alcoholic beverages some 10,000 years ago. Basically, vinegar may be regarded as wine spoiled by the acetic acid bacteria, but for which other uses have been found. Historically, as the most easily available mild acid, it had a great variety of industrial, medical and domestic uses, some of which, such as its use as a general household cleanser, are still promoted today. Although acetic acid is the major component of vinegar, the material cannot be produced simply by dissolving acetic acid in water. When alcoholic fermentation occurs and later during acidifications, many other compounds are produced, depending mostly on the nature of the material fermented, and some of these find their way into vinegar. Furthermore, reactions also occur between these fermentation products. For example, ethyl acetate is formed from the reaction between acetic acid and ethanol. It is these other compounds which give the various vinegars with organoleptic properties. The other compounds include non-volatile organic acids such as malic, citric, succinic and lactic acids, unfermented and unfermentable sugars, oxidized alcohol and acetaldehyde, acetoin, phosphate, chloride and other ions. Commercial vinegar is produced either by fast or slow fermentation processes. In general, slow methods are used with traditional vinegars, and fermentation proceeds slowly over the course of months or a year. The longer fermentation period allows for the accumulation of a non-toxic slime composed of acetic acid bacteria. Fast methods add mother of vinegar, that is bacterial culture, to the source liquid before adding air to oxygenate and promote the fastest fermentation. In fast production processes, vinegar may be produced in 20 to 72 hours. Types of vinegar. Vinegar is normally a product of two fermentations: alcoholic fermentation with a yeast and the production of acetic acid from the alcohol by acetic acid bacteria. There is no distillation between the two fermentations except in the production of spirit vinegar. The vinegar may or may not be flavored. The substrate for the alcoholic fermentation for vinegar production varies from one locality to the other. Thus, while wine vinegar made from grapes is common in continental Europe and other wine growing countries, malt vinegar is common in the United Kingdom. The United States, on account of its great variety of climatic reason, uses both malt and wine vinegars. Rice vinegar is common in the far eastern countries of Japan and China, and pineapple vinegar is used in Malaysia. In some tropical countries, vinegar has been manufactured from palm wine derived from oil or raffia palm. The composition and specifications of various types of vinegars are defined by regulations set up by the governments of different countries. In the United States, for example, vinegar should not contain less than 4% acetic acid and not more than 0.5% ethanol. The various major vinegars are defined briefly as follows. Cedar vinegar, apple vinegar. These vinegar produced from fermented apple juices and non-grape fruits. Wine vinegar, grape vinegar. These vinegar fermented grape juice malt. Malt vinegar produced from a fermented infusion of barley malt with or without adjuncts. Sugar, glucose, dried fruits vinegar. In the US, vinegar from sugar syrup or molasses should be labeled sugar vinegar, while that from glucose, which should be dextrocerotary, and dried fruits should be labeled with glucose or the particular fried fruit involved. Spirit vinegar. Vinegar made from distilled alcohol in the United States. Synonyms for spirit vinegar are white distilled vinegar and grain vinegar. The alcohol used in the distillation is denatured for tax reasons with ethyl acetate. 1 gallon of ethyl acetate is usually added to 100 gallon of 95% alcohol. The ethyl acetate is not deleterious and in any case is present in vinegar by the alcohol acetic acid reaction. It should be noted that in the United States, the term distilled refers to the ethanol used. In the United Kingdom, however, distilled vinegar refers to a distillate of malt vinegar. Some specialty vinegars. Some specialty vinegars make up a category of vinegar products that are formulated or flavored to provide a special or unusual taste when added to foods. Specialty vinegars are favorites in market are herbal vinegars. Wine or white distilled vinegars are sometimes flavored with the addition of herbs, spices or other seasonings. Popular flavorings are garlic, basil and tarragon, but cinnamon, clove and nutmeg flavored vinegars can be tasty and aromatic addition to dressings. Fruit vinegars. Fruit or fruit juice can also be infused with wine or white vinegar. Raspberry flavored vinegars, for example, create a sweetened vinegar with a sweet sour taste. Balsamic vinegar. Traditional balsamic vinegar of Modena, Italy is made from white and sugary Trebbiano grapes grown on the hills around Modena. The grapes are harvested as late as possible to take advantage of the warmth of the weather. The traditional vinegar is made from the cooked grape must, that is juice, matured by the long and slow processes of natural fermentation, followed by progressive concentration by aging in a series of casks made from different types of wood and without the addition of any other spices or flavorings. The color is dark brown and the fragrance is distinct. Production of traditional balsamic vinegar is governed by the stringent standards imposed by the quasi-governmental consortium of products of the traditional balsamic vinegars of Modena. Raspberry red wine vinegar. Natural raspberry flavor is added to red wine vinegar, which is the aged and filtered product obtained from the acetous fermentation of select red wine. Raspberry red wine vinegar has a characteristic dark red color and a tangy yet delicate raspberry flavor. Other specialty vinegars, coconut and cane vinegars are common in India, the Philippines and Indonesia, with date vinegar being popular in the Middle East. Organisms involved. Pasteur confirmed that acetic acid is produced only in the presence of the bacteria, but he did not identify them. The genus name Acetobacter was put forward by Beizernik in 1900. Suffice it to state that although Acetobacter species are responsible for vinegar production, pure cultures are hardly used except in submerged fermentation because of the difficulty of isolating and maintaining the organisms. The only member of the genus which is not useful, is not positively harmful in vinegar production is Acetobacter xylenum, which tends to produce slime. Recently, a new species Acetobacter europaeus was described. Strains of acetic acid bacteria to be used in industrial production should tolerate high concentrations of acetic acid, require small amounts of nutrient, not over oxidize the acetic acid formed, and be high yielding in terms of the acetic acid produced. The bacteria converting alcohol to acetic acid under natural conditions are film forming organisms on the surface of wine and beer. The film was known as mother of vinegar before its bacteriological nature became known. The bacteria were first described as mycoderma, that means viscous film, in 1822. Later, other workers classified them in a Mycoderma vineae, that is forming film on wine, and Mycoderma acetic, that is forming film on beer. Manufacture of vinegar. The three methods used for the production of vinegar are the Orland's method, also known as slow method, the trickling or quick method, and submerged fermentation. The last two are the most widely used in modern times. The Orland's or slow method. The oldest method of vinegar production is the let alone method, in which wine left in open vats became converted to vinegar by acetic acid bacteria entering it from the atmosphere. Later, the wine was put in casks and left in the open field in the fielding process. A small amount of vinegar was introduced into a cask of wine to help initiate fermentation. The introduced vinegar not only lowered the pH to the disadvantage of many other organisms, but also introduced an inoculum of acetic acid bacteria. The casks were wooden and of approximately 200-liter capacity. It was never filled beyond about 2/3 of its capacity, so that there was always a large amount of air available above the wine. A thick film of acetic acid bacteria formed the wine and covered it into vinegar in about 5 weeks. About 10 to 20% of the vinegar was drawn off at weekly intervals and replaced with new wine. The withdrawal and replenishment were done from the bottom of the cask so that the film would not be disturbed. Often, a series of casks was present and transfer was done from one cask to another. The process had a number of disadvantages, such as it was slow in comparison with later methods, taking up to 5 weeks, sometimes as against days. Hence, it is also known as the slow method. It was inefficient, yielding 75 to 85% of the theoretical amount. The mother of vinegar usually gradually filled the cask and effectively killed the process. The second method, the trickling generators quick method. Credit for devising the forerunner of the modern trickling generator is usually given to the Dutch scientist Boerhaave, who in 1732 devised the first trickling generator, in which he used branches of vines and grape stems as backing. Improvements were made by a number of other people from time to time. Later, ventilation holes were drilled at the bottom of the generator and provided a mechanical means for the repeated distribution of the alcohol acetic acid mixture over the packing. The heat generated by the exothermic reactions in the generator caused a draft which provided oxygen for the aerobic conversion of alcohol to acetic acid. This latter model of the quick method, sometimes called the German method, enabled the production of vinegar in days instead of in weeks. The modern vinegar generator consists of a tank constructed usually of wood, preferably of cypress, and occasionally of stainless steel. A false bottom supports the coils of birch wood shavings and separates them from the collection chamber, which occupies about 1/5 of the total capacity of the generator. A pump circulates the alcohol acetic acid mixture from the reservoir through a heat exchanger to the top of the generator, where a spray mechanism distributes it over the packing in much the same way as a trickling filter functions in wastewater treatment. Air is forced through the false bottom up through the setup. The cooling water in the heat exchanger is used to regulate the temperature in the generator so that it is between 29 degrees Celsius to 35 degrees Celsius, that is determined with thermometers placed at different levels of the generator. The top of the generator is covered, but provision exists for exhaust air to be let out. Meters measure three parameters: A, the circulation of the mash, and the B, the flow of the cooling water through the heat exchange, and C, the amount of air delivered through the system. If the air flow rate is too high, alcohol and vinegar are lost in effluent air. The trickling or circulating fringe generator is reasonably efficient, achieving, when operating maximally, an efficient of 91 to 92%, and it is capable of producing 500 to 1000 gallons of 100 grain, that is 10% vinegar every 24 hours. The finished acidity of the vinegar is about 12%. When it is higher, production drops off. In order to exceed this level of acidity, when drawing off vinegar, the amount of alcohol in the replacement should be such that the total amount of alcohol is less than 5%. Submerged generators. With knowledge in submerged fermentation gained from the antibiotics and yeast industry, it is not surprising that vinegar production was soon produced by this method. Several submerged growth vinegar generators have been described or are in operation. The common feature in all submerged vinegar production is that the aeration must be very vigorous, as shortage of oxygen because of the highly acid conditions of submerged production would result in the death of the bacteria within 30 seconds. Furthermore, because a lot of heat is released, over 30,000 calories are released per gallon of ethanol, an efficient cooling system must be provided. All submerged vinegar is turbid because of the high bacterial content and have to be filtered. Some commonly used submerged generators will be discussed below. Frings acetator. First publicized in 1949, most of the world's vinegar is now produced with this fermenter. It consists of a stainless steel tank fitted with internal cooling coils and a high-speed acetator fitted to the bottom. Air is sucked in through an air meter located at the top. It is then finely dispersed by the agitator and distributed throughout the liquid. Temperature is maintained at 30 degrees Celsius, although some strains can grow at a higher temperature. Foaming is interrupted with an automatic foam breaker. Essentially, it is shaped like a typical aerated stir tank fermenter. Advantages: the efficiency of the acetator is much higher than that of the trickling generator. The production rate of the acetator may be tenfold higher than a trickling unit. Values of 94% and 85% of the theoretical have been recorded for both the acetator and the trickling filter respectively. The quality is more uniform and the inexplicable variability in quantity noted for the trickling generator is absent. A much smaller space is occupied, about 1/6 in comparison with the trickling generator. It is easy and cheap to change from one type of vinegar to another. Continuous production and automation can take place more easily with Frings acetator than with trickling. Disadvantages: a risk exists of complete starve phase following death of bacteria from power failure even for a short time. Automatic standby generators have helped to solve this problem. It has a high rate of power consumption. Some authors have, however, argued that in fact, in terms of power consumption per gallon of acetic acid produced, the acetator is less power consuming. The cavitators. The cavitator was originally designed to treat sewage. It was then modified for vinegar production. In many ways, it resembled the acetator. However, the acetator was fixed to the top and finely dispersed air bubbles are introduced into the liquid. It operated on a continuous basis and was quite successful in producing cedar and other vinegars as long as the grain strength was low. The tower fermenter. The tubular or tower fermenter, developed in the UK, has been used on a commercial scale for the production of beer, vinegar and citric acid. It has a working volume of 3000 liters and aeration is achieved by the stainless steel perforated plate covering the grass section of the tower and holding up the liquid. The unit can produce up to 1 million gallons, that is 4,50,000 liters of 5% acetic acid per annum. The Acetobacter species requires a month to adapt to the new system. The system can be batch, semi or fully continuous without noticeable differences in the quality of the product. Processing of vinegar, clarification and bottling. Irrespective of the method of manufacture, vinegar for retailing is clarified by careful filtration using a filter aid such as diatomaceous earth. Vinegar from trickling generators are, however, less turbid than those from submerged fermentation because a high proportion of the bacterial population responsible for the acidification is held back on the shavings. After clarification, it is pasteurized at 60 to 65 degrees Celsius for 30 minutes. Concentration of vinegar. Vinegar can be concentrated by freezing. Thereafter, the resulting slurry is centrifuged to separate the ice and produce the concentrate. With this method, 200 grain, that is 20% weight by volume of acetic acid, can be produced. Concentration is necessitated by two considerations. One is the consequent reduction in transportation cost. The other is the need to prevent loss of activity of the vinegar when cucumbers were picked in it after first being soaked in brine. Uses of vinegar. Ancient uses. The ancient uses of vinegar, which can be seen from various records, includes use as a food condiment, treatment of wounds, and a wide variety of illness such as plague, ringworms, burns, lameness, varicose veins. It was also used as a general cleansing agent. Finally, it was used as a cosmetic aid. Modern uses. Vinegar is used today mainly in the food industry as a food condiment sprinkled on certain foods such as fish at the table. For pickling and preserving meats and vegetables, vinegar is particularly useful in this respect as it can reduce the pH of food below that which even spore farmers may not survive. It is an important component of sauces, especially renowned French sauces, many of which contain vinegar. Nearly 70% of the vinegar produced today is supplied to various arms of the food industry, where it finds use in the manufacture of sauces, salad dressings, mayonnaise, tomato productions, cheese dressings, mustards and soft drinks. Most of the vinegar used in industry is the distilled or concentrated. In conclusion, throughout history, vinegar has proved to be the most versatile of products. The dictionary defines versatility as capable of turning with ease from one thing to another, and from more than 10,000 years ago to today, consumers continue to use vinegar in a variety of ways. Vinegar is now mainly used as a cooking ingredient. Historically, as the most easily available mild acid, it had a great variety of industrial, medical and domestic uses. Thank you.